Hi everybody, my name is Paul Calvano. I'm a web performance architect at Akamai. So today we're going to talk about tracking the performance of the web with the HTTP archive. So my role at Akamai is to really help customers like you get the most out of our platform. Frequently doing like deep dive performance analyses with customers, and a lot of times when I'm looking to figure out try to answer some creative problems that I'm seeing people run into, I use a variety of different tools, and one of them is the HTTP archive. I also have Rick Viscomi from Google here. Rick, do you want to introduce yourself?
Sure. Thanks, Paul. So I'm Rick Viscomi. I work at Google, and I am a developer programs engineer under the developer relations team. And my day-to-day job is on HTTP archive. I'm a tech lead, and I've been doing this since about 6 months ago. Before that, I spent 4 years at YouTube as a performance engineer. So I care deeply about web performance, and I'm actually really excited to join this team because I went from working on the performance of one website, it happens to be like the number 3 website in the US, YouTube, to now working on the performance of the web as a whole. So it's been a great experience for me. Can we see a show of hands of people who have heard of HTTP archive before? Many of you, good. So for those who don't know, I might close it. The HTTP archive tracks how the web is built. It was created in 2010 by Steve Souders. He's kind of the godfather of web performance. He wanted to measure how websites are built by using all of the metrics that web page test exposes, including how many bytes of JavaScript or how many images are on the page, low-level information about the network activity, when resources were loaded, how long they took. So anything you can imagine you can learn about a web page, we track over time for 500,000 websites on both desktop and mobile twice a month. So as you can imagine, it's a very large-scale operation. And when you go to the website, httparchive.org, this is what you'll see. Those 2 parts of the mission that Steve wrote, tracking how the web is built, are exposed here on the stats and trends page. So for any given crawl, you can see low-level statistics about each of those web page test metrics I described. And also trends. You can see how those metrics have changed over time. Many of the metrics go back all the way to 2010 when the project started. And as we've been adding more and more functionality, you can now see things like progressive web appiness metrics. We've recently integrated the Lighthouse tool, so that now you have 80 more PWA metrics exposed by this tool. But this is all you see when you go to the website. You just see some curated stats and trends that we've handpicked over the years. They're high-level stats. They don't answer every burning question you may have. So we'll get to what we're doing to address that in a little bit. Like I mentioned, we track 500,000 websites. We decide which websites are included in that crawl by looking at the Alexa ranking. They have a list of 1 million sites and their corresponding rankings, and we take the top 500,000. We would crawl more, but our infrastructure unfortunately can't support any more websites to stay within that 2-week crawl limit. We only crawl the home pages of websites. Some people might think that we, may crawl Gmail. That's a very popular website, but we can't see your particular inbox, and we need to have a logged-in experience to do that. So we just do the logged-out homepage on both desktop and mobile. It is powered by web page test, so it captures all of these performance and tracing metrics, exposes them in a HAR file, which coincidentally stands for HTTP archive file format. It also executes custom metrics. So if you can execute any JavaScript on the page, for example, one of the custom metrics that Steve wrote is to count the number of iframes on the site. So we can get any custom information that way. And it also records these Lighthouse audits. And an audit in this case is testing if a website passes certain criteria. For example, does it have a time to interactive below some, or above or below some threshold to consider the website fast? We expose all this information on the httparchive.org website, on the stats and trends pages, but we also have this discussion forum where people will drill down onto the BigQuery and Google Cloud Storage data sets and find out more interesting information that they might be wondering that is not exposed in the UI. And this is really the key to this whole entire talk is Interesting information does not only lie on the website. You need to go in there and dig for it. This is another way to view the architecture. We're hosted by the Internet Archive, who you may know as the people behind the Wayback Machine. So they have a tool that allows you to see how a website looked at any given point in time that it's been alive and crawled by their service. And it's actually interactive. You can go in there and click a link and see a page as it would have appeared at the time. But HTTP Archive is collecting metrics over time about how the web is built under the hood. And so it uses 134 different private instances of web page test. We need that to make sure that the 500,000 websites, or actually 1 million total if you count desktop and mobile, complete bi-weekly on schedule. Finally, HTTP Archive puts all that information into these Google Cloud Services, BigQuery, and Cloud Storage. So the website above the surface exposes these curated stats and trends, but all that raw data is available. I call it it's like the tip of the data berg. Whatever you see exposed on the website is just the tip of the iceberg. So we really want to get in there and mine it. So to convince you that this tool is well received by the community, I'll give you a few examples of who's using it. Scholars have used it to support their research papers. For example, publications in ACM and IEEE have cited HTTP Archive data. The community uses it. Eric Lawrence says, the HTTP Archive is pretty awesome sauce. I don't even know what I'm doing, and I can still use it. And he goes on to provide some interesting information about Brotli compression. A couple of years ago, Tammy Everts, while she was with SOSTA, wrote a blog post about how the average web page size is now exceeding 2 megabytes. And that was pretty big news at the time. Another milestone was reached when the average web page exceeded the size of the original game Doom, and it was actually picked up by Wired on their online site. This is an important time to note that averages, when used with big data, is not necessarily entirely accurate or representative of the data set. We much prefer to look at medians, and this is one of the things that we're going to be changing with the new site. We're working on a beta site, so if you go to beta.httparchive.org, you'll see that we're now focusing on medians and percentiles instead. So fun fact, if you were to look at the median size of a web page, it's more like 1.4 megabytes as opposed to the 3 megabytes it is today. So we might be hitting this Doom milestone again in the near future. And finally, industrial tools are also using HTTP Archive to calibrate their tools. Lighthouse on the left is calibrating one of their audits to make sure that the size of the page is not exceeding some crazy limit. On the right, we have a tweet thread involving Sean Larkin from Webpack. They use HTTP Archive data to sanity check the size of your JavaScript bundles. So now I'm going to pass it off to Paul, and he's going to tell you about some more interesting and actually really, really cool, personally, I'm excited about these use cases. Paul.
All right, so thank you, Rick. So we're going to look at a couple of case studies. The first case study, we're going to focus on compression. So we're going to look at both gzip compression as well as Brotli compression. For those of you that have been Akamai customers for a while, you probably recognize this interface. This is last mile acceleration. It's essentially gzip compression at the edge, and this was from our old portal, probably prior to 2012, 2013. The way that it works is that if we compress your resources by the content type. So if you didn't compress something at the origin, we will compress those resources if it matches the content types that are configured in last mile acceleration. In this case, text/HTML, application/x-JavaScript, and text/CSS. One of the things that I noticed when I joined Akamai was that a lot of these default content types weren't catching everything, and sometimes we would need to update them and add content types on a per customer basis. But when Property Manager was introduced, we decided to update this. When we're having discussions about how to, which content type should we make, which should we use for the new defaults, one of the things that we were thinking about doing is let's look at, all the configuration options and see, what have people done to, plug the gap of these three. But another route that we decided to go is running a query like this. And what you're seeing here is a SQL query that looks at MIME types, so essentially content types, and then sums the number of resources across all 470,000 websites that are being gzip compressed, deflate compressed, that are not being compressed, and then also looking at the percentage of the compressed resource. So when we run this query, and this runs really quickly in BigQuery, what we wind up getting is a table here that essentially shows us all of the different content types that are the most popular content types. And one of the things that you'll notice here is that there's a lot of content types that were not being caught by our original defaults. Text/JavaScript, font/TFF, application/JavaScript. So these content types did not match the original defaults, and this gave us a real good data point to say this is what we should base our new defaults on. So a few years ago, you may have started seeing this. Whenever you would configure last mile acceleration or introduce a new Akamai property, you'd wind up seeing these defaults. So when you see this is actually based on HTTP archive data, and that's where we actually wind up getting the content types for that. But what about Brotli? So Brotli is a new compression algorithm. It was developed by Google researchers. It's actually named after a Swiss pastry. But with Brotli, you wind up getting a 5 to 25% reduction over gzip compression. It's supported by most browsers today, which is really great. So let's extend the previous query to include Brotli compression. So what I've done is when a browser advertises support for Brotli, it'll basically say accept encoding BR, and the content type in the response will say content encoding BR. So I can just add a line here. I added in line 3, if content encoding is equal to Brotli, then output that. And then I also have, I added a Brotli compressed percentage to this query. When I run this, I wind up getting a list of resources that are using Brotli compression. 10% of HTML on the web, and this was from last month, are actually being Brotli compressed. 16% of JavaScript. These are really high numbers for something that was relatively new. Peeling into the data, I was able to see that a lot of the Brotli compressed resources, especially the ones for JavaScript and HTML, were actually Google and Facebook. So when you see a Facebook like button on a page, that's most likely Brotli compressed, and that's why it's showing up so high. But if we wind up eliminating Google and Facebook from the results, we wind up seeing that most of the Brotli compressed resources typically focus around text-based content, and it's usually JavaScript or CSS. HTML isn't as prevalent except for Facebook and Google, and one of the reasons why we're seeing that in particular is because of the overhead that you wind up getting with compression. So if you look at the bottom part of this, table here, gzip compression goes from 0 to 9. And there's a direct relationship between the compression ratio you get and the compression speed. The higher you compress, the smaller the file gets, but the longer it takes. And this is measured in megabytes per second. So when you're looking at a 300 kilobyte file, it's going to take a very short amount of time. But still, that's time. And when we're trying to squeeze every millisecond out of performance, we don't want to introduce any more delays than we have to. If you look at Brotli, you'll notice that once you get high enough in the Brotli compression, it actually becomes significantly slower, but the compression ratio is a lot higher. Instead of a 3.21 compression ratio, you can see a 4.6 compression ratio, but that half a megabyte per second is incredibly slow. So it's while you might want to turn it up to 11. There's certainly some concern that you have to have there. So what we wound up doing at Akamai is we took Brotli, which that's actually a picture of Brotli, within Akamai we wound up creating a feature called Resource Optimizer. Now, Resource Optimizer, you may notice that there's just like an enable toggle that's turn it on or off. It really is that simple to configure. This is something that's in beta today, and the way that this works is it automatically compresses your CSS and your JavaScript with Brotli at compression level 11, and it does the compression offline, similar to the way Image Manager works, where asynchronously it's doing the compression for you, and then it just loads it into our caches so that when a subsequent user comes, we can serve those resources Brotli compressed. But HTTP Archive was able to help us really understand the way that the industry is using this and to be able to track that over time. So I want to talk about another case study around server technologies. One is the Akamai Varnish connector, which if you've talked to our friends at Varnish over in the booth over here, you've probably seen what the great things that they're doing. And also about server vulnerability research. So the Akamai Varnish connector allows you to essentially control Akamai from Varnish at your origin. So it gives you that kind of bridge where you can create, within VCL, the ability to trigger certain types of events within the Akamai platform. Months ago, when we first started talking about this product, I was approached by Akamai's product management, and the conversation basically went like, hey, we're building out a free product for Akamai customers. We want to understand which Akamai customers use Varnish at the origin. You know, we're not typically embedded in the origin. Who should we talk to? So what I wound up doing is I ran a SQL query. I wanted to first examine how can I try to identify Varnish via HTTP archive? So I started exploring the data, looking at the schema of the BigQuery tables, which we'll show you how to do that later. And I was able to find that there's certain columns that can indicate which resources. There's certain columns that can indicate to you where things may be served from. So, for example, the response other headers column can give you a lot of information that you can mine, like server information. Same thing with response server, response via, x powered by. I wound up writing a query that essentially looked at, so you can see count $sign, or count asterisk for uses Varnish, and then I also have on line 2 I'm looking at the number of websites that use Varnish for in the Alexa top 100,000, and I call that likely high traffic. What I was able to tell here is sites that actually advertise that they use Varnish in their response headers. It's probably more than this. There's around 746 Akamai customers that likely use Varnish, and around 396 of them are in the top 100,000 sites. So digging into this a little bit deeper, we were able to give product management at Akamai some insight into which specific customers we should go and talk to say, hey, we're building out this free product. What would make it most useful for you? And all of that came from the HTTP archive. Another example is investigating security threats. So when I work primarily on the web performance side at Akamai, but there's kind of a Venn diagram between performance and security. So one of my customers had I had noticed that they basically were attacked with a 0-day vulnerability on and that vulnerability was specific to a certain e-commerce app server. There was no CVE or historical attack patterns. Our Kona managed security team was able to mitigate it very quickly. There was no compromise. The WAF rules were prepared, so they had a custom rule in place to basically patch what was an unknown vulnerability at the time, and the vendor was notified. So the vendor was able to go and apply the patch and notify their customers. But one of the things that we see when we're looking at security is that if someone is as aggressive to go and use a 0-day vulnerability to attack someone, they're going to go and they're going to attack someone. If they're not successful, they're going to attack the next site and then the next site and so forth. So we wanted to notify customers and say, hey, we think you're using this application server. We can patch it for you until the official patch is released. So what we wound up doing was we went through the HTTP archive, similar to what you saw with Varnish. We were able to investigate sites that contain similar characteristics, looking at the server, looking at the via header, URL regular expression patterns, other headers, identify what we actually saw on the in the attack, and then export that data. Cross-reference that with some Akamai information. So I was able to actually able to create a list from the HTTP archive of websites that were likely to be vulnerable, and I had a few dozen, and then also correlate that with Akamai account teams as well as 24/7 security contacts. Hand that off to our SOC, and they were able to go notify people and say, hey, there's a 0-day. Your vendor probably notified you. Would you like us to patch it for you until it's fixed? So this is how powerful this data can be, and it really crosses a lot of different use cases. We've looked at performance, we've looked at security. There's also another way that we can look at this with security as well. So Rick mentioned that the HTTP archive tracks Lighthouse reports for mobile sites. Lighthouse is great for looking at basically best practices for progressive web apps. One of the and the team is constantly building out new features within Lighthouse. But one of the things that was introduced last week actually was support for SNCC security audits. If you're not familiar with SNCC, SNCC is a security service that can monitor your code base to look for known vulnerabilities in your software. It was actually founded by a former CTO of Akamai. Really great company. If you haven't seen it before, I would check it out. But in this case here, you can see that the particular website I ran it for has a vulnerable jQuery library, and then that link there would actually bring me to a page that shows me the specific details on what's vulnerable in this jQuery library. Now, this was just introduced last week into Lighthouse, but because it's in Lighthouse, it's going to wind up showing up in next month's HTTP archive data. So I can almost bet that the data that's going to be collected from this is going to create some interesting industry buzz about third-party libraries that are deployed that are vulnerable and so forth. And this is another great extension of there's always new data that shows up in the data that's just on the web, and we can track that over time and identify new use cases for this. Another case study: third-party research. So I had posted something on the HTTP archive discussion forums, and it created a bit of interest in the industry about how third parties influence render time. Everybody knows third parties influence render time, but which third parties influence render time, and how do they influence it? So I ran this scary looking query, which is basically taking a look at HTTP requests and page requests and looking at when the HTTP request was initiated compared to when the page started to render. And I was able to correlate which third-party content types were most likely to impact render time. And I was actually surprised to see images were the most likely to impact render time. I wound up doing this for the Alexa Top 100, the Alexa Top 1000, Top 10,000, Top 100,000, and all sites. And I also found that there was some differences in the way that the sites had render blocking content based on their popularity. For example, on the top 100 sites, most of it was image based. In the top 1,000 sites, we have images in JavaScript. In the top 10,000, we started introducing third-party fonts. So it kind of shows you a little bit about where render blocking content is being applied, and it gives you a lot of insight that you can go and maybe have other questions that you want to dig into and ask and learn from. I wound up taking this data. And you'll notice that the first line is really the only thing that's different about this. Line 1 and line 15, where I basically grabbed the third-party host name. And this gave me a list of third-party hosts. And you can see that Google and Facebook show up prominently in there. But they're not the only ones that are render blocking. This is just kind of the tip of the iceberg. This is actually kind of a map of the top, I would say the top 25 third parties. And the darker the color, the higher likelihood that content type is going to be render blocking. And across the top are different types of content. So whether it's CSS or JavaScript or HTML or fonts. In here, we're actually able to see a lot of third-party A/B testing tools and a lot of third-party third-party fonts and things like that. Some third-party image providers are showing up in here, but this is really insightful for us to kind of understand as an industry what's blocking render time. But let's say I want to make this something customer specific, and I actually did this research for a specific customer where they actually asked me, hey, there's a specific third party that we're trying to identify what's they appear to be blocking our render time. Who else is using this third party, and how likely is are they blocking the render time for other websites? So one of the things I did here is I included in the first line the site, so the URL of the page, and then I also included in the where clause over here incitin.com. So I want to track for this particular third party, which sites are using it and how many resources are render blocking versus non-render blocking. The output here, just to kind of show you the top few. I can see that there are some pages like hotels.com or Dell.com and B&H Photo that have no render blocking resources for Incitin. There are some that have a lot, like hotels.com and autodesk.com, have a lot that load after the page starts to render. And then there are some that it's just varied. And it's not to say that any of these implementations are wrong, any of them are not performant. It's really different implementations from different sites and different industries. But if this was you and you were trying to understand how to optimize, let's say, this particular third-party tag, this can give you some more insight rather than going and looking at, let's say, a commerce competitor and saying, I work for this commerce company, I want to understand how three other commerce customers use this. You can actually go learn from an airline or a newspaper magazine or a financial site, because they're all using similar technologies, and you can actually get that data from the HTTP archive to help you do some investigation and analysis. So how do we get started with this? When I first started using HTTP Archive, it was after I saw Ilya Grigoryk's Velocity Keynote presentation in 2013, where he actually did a demo of this and showed how to query the data with BigQuery. So the instructions for that are kind of out of date at this point because both HTTP Archive and BigQuery have evolved. So I wound up creating, in the top right, you'll see a bit.ly URL. That's actually a URL that will go to some documentation on how to actually get started with this. But it's really simple. You can do it in less than 10 minutes. And those instructions take you from, I have a Google account, to running queries like that. And all of the queries that you saw on those previous pages had a URL just like that one, that if you click on that, it'll take you right to the BigQuery query where you can actually have the query loaded in there, and you'll be able to actually just run it straight from there. Now, when you do this setup, Google gives you a $300 credit to just get started with the cloud services. And then there's also a free tier, so you can process 1 terabyte of data per month for free. Most of the queries that you see here will fall below that. I do a lot of querying with the HTTP archive. I hardly pay anything for it, so it's not something that's gonna break the bank. But to get started, you go to cloud.google.com/project create. You basically just enter a project name, create a project. It could be anything you want. Then you go to bigquery.cloud.google.com, and in the project that you created, you go to create it, switch to project, display project, and enter HTTP archive. From there, you can just follow the detailed instructions, but there's some, which walks you through the table structure and the layout and how to run queries. This is the query that it takes you to run, which is basically a summary of MIME types across all 470,000 sites. There's also some standard SQL documentation as well as a discussion forum where you can both post some of your research and analysis, ask questions, ask for help, or just read some of what the community is talking about. I'm going to turn it back over to Rick now.
Thank you, Paul. So some of the new things in HTTP Archive that we're really excited about, we've mentioned Lighthouse integration, vulnerability detection with SNCC through Lighthouse, and more generally, we're able to detect third-party JavaScript libraries now. For example, recently there was a blog post on the discussion forum about an analysis of the most popular JavaScript libraries. Lo and behold, jQuery, the most popular with 80% of the web. Thanks in part to WordPress, but we don't yet know which sites are hosted on WordPress. So coming up soon, we're going to be able to detect platforms like WordPress and others. We're going to launch this beta site with curated reports, improve data visualization. You might have noticed from the initial screenshots that some of the charts are a little outdated. They're very flat. They're non-interactive. We're going to be integrating high charts interactions in there, so it should actually be really enjoyable to use. I'm also working on a video series where I'll be diving deep into this data and sitting down with some industry professionals to learn more about the trends on the web. There are some things that are coming soon, but we don't quite have a milestone yet on the roadmap. For example, website categorization. We'd really like to know, is this an e-commerce site? Is this a travel site, news site? Because if we can slice the data in these ways, we can find out interesting ways that websites of a similar kind are having performance problems, and we can resolve these issues systemically. We also want to scale up our operation. Right now, we're testing only 500,000 sites, but the web is huge. The long tail is very, very long, and we want to know the performance of the web as a whole, ideally. So we're trying to scale up to millions of tests. The goal for 2018 is 5 million sites on both desktop and mobile. As you might imagine, doing so kind of requires crazy hardware, so we really need to thank our sponsors, the Internet Archive. The sponsors in the middle here have been with us for many years, and now I'm very, very excited to announce that Akamai is a sponsor officially as of maybe yesterday or today of HTTP Archive. So thank you to our sponsors for making it possible. If any of you out here have a company who maybe have used HTTP Archive in the past, or if you think it's a valuable resource for the web and you might consider becoming a sponsor, you can contact us at team@httparchive.org. Our website also has some information on there. We're a nonprofit organization. We only depend on our sponsors to stay active. If you'd like to learn more about the project, you can read. We're open source. We're on GitHub. We've dropped it a few times. We're really excited about our discussion forum. There's lots of interesting things happening on there. If you need help writing your queries, if you'd like to better understand how the data sets are set up, visit us at discuss.httparchive.org. We have many, many people who are just willing to help. And we also have a Slack channel. Because Internet Archive actually used the free nonprofit Slack account. So we have to have this like lower than that free Slack channel. So I can't open it up for anybody who's a guest to join on their own. So you need to follow this link. It's a form. You can submit your email address, and I'll send you an invitation. And Paul, would you like to make a comment about the discussion forum?
Sure. So yeah, this is just a screenshot from a recent discussion forum. You can see there's a lot of really cool discussions that are happening on there. Even as recently as yesterday, you'll notice that Rick and my logos or faces are showing up in there. We're very active in the discussion forum. Definitely jump in there. Join us. Share some analysis. Ask questions. We'd love to hear from you.
Absolutely. Also, before we close out, thank you, by the way, for staying out here. We know it's the end of the day. We also have some T-shirts to give out, so come up to the stage after we're done, and we'll be happy to hand those out. Here again is our information. Contact us on Twitter if you have any questions. We're going to be posting a link to the slides. Our email addresses are here if you have any other more detailed questions that don't fit into 140 or 280 characters. So thank you again.